In this video, we will be going through the four major types of reactions, which are synthesis, decomposition, single displacement, and double displacement. Let's start with synthesis. So synthesis involves the combination of smaller atoms and/or molecules into larger molecules. That means that you're going to see two or more reactants combining to make one product. If we were to generalize this, then you would have A reacting with B to create a compound AB. Looking at an example of synthesis, an example would be hydrogen plus iodine reacts to give hydrogen iodide. Now let's take a minute and write this out. So hydrogen and iodine are both diatomic, and that is going to produce HI. To balance, we're going to put a 2 in front of the HI, and this would be an example of a synthesis reaction because we have two elements combining to make one compound. Decomposition is the opposite to synthesis. It involves the splitting of a large molecule into elements or smaller molecules. So one reactant is going to break apart into two or more products. If we were to generalize this, we would write our molecule AB reacts to give two components A plus B. Looking at an example then, we could look at the decomposition of water. So dihydrogen monoxide is just water, and that's going to react to give hydrogen gas and oxygen gas. Okay. Again, we'd want to balance this, so we're going to put a 2 in front of the water and a 2 in front of the hydrogen. Gives us a balanced reaction, so we can see that a molecule is breaking down into different components. Single displacement, there are a couple scenarios that we're going to look at. Single displacement involves one element displacing or exchanging places with a second element in a compound. So in our first scenario, a metal can displace a metal in a compound. If we were to generalize this, our general equation would look like the following. We would have A plus XY reacts to give X plus AY. In this scenario, A and X are both metals. Remember, metals are always written first in a chemical formula. And Y then would be a nonmetal. Okay, so the metal A is swapping places with the metal X in order to form a new compound AY and leaving X by itself. Let's look at an example. So we're going to have sodium reacting with zinc chloride, so ZnCl2, and that's going to produce sodium chloride and zinc. Let's just balance this quickly. So we need a 2 in front of the sodium chloride and a 2 in front of the sodium. Okay, so what you can see is sodium is a metal and zinc is a metal, whereas chlorine is our non-metal. So sodium and zinc are swapping places to make sodium chloride and zinc by itself. Our second scenario is when a nonmetal displaces another nonmetal in a compound. So in this scenario, B and Y are nonmetals, and X is our metal. So remember, a nonmetal is always written as our second element in a compound. So in this scenario, the nonmetals are going to swap place. So B plus XY is going to give Y, this is our nonmetal by itself, plus our new compound XB. So B being our new nonmetal in our compound. An example of this would be fluorine. So fluorine, remember, is always diatomic, plus sodium chloride reacts to give chlorine, which is diatomic, and sodium chloride. So we just need to balance again. We're going to put 2's in front of the sodium chloride and sodium fluoride. Now what you should notice here is that fluorine and chlorine are non-metals, so they are swapping places, and that's going to produce sodium fluoride and chlorine by itself. Be really careful with single displacement reactions. Make sure you're swapping metal for metal or non-metal for non-metal. Do not swap a metal with a non-metal. Alright, last type of reaction is our double displacement. So that involves both elements in different compounds displacing each other. And so this means that the metals are going to switch places with each other. In our general equation here, A and X are both metals, whereas B and Y are non-metals. Sorry, my pen's super squeaky today, not sure if you can hear that. So in a double displacement reaction, the metal of one compound swaps with metal of the other compound. So that is going to form XB and AY. Looking at an example, silver nitrate. So we got to think about our formulas here. Silver nitrate is AgNO3 plus sodium chloride. It's going to react to give sodium nitrate and silver chloride. Okay, so we're already balanced here. Now what you have to recognize is that our silver and our sodium are our metals, and they are swapping places. Our nitrate and our chlorine are our non-metals. So when the silver and the sodium swap places, that gives you sodium nitrate and silver chloride. Now you can get a double displacement where you have where you have hydrogen and it acts like a metal. A really good example would be a neutralization reaction. So let's take something like sodium hydroxide and react it with hydrochloric acid. That gives sodium chloride and water. So I'm just going to write water out like this because the hydrogen in HCl is acting like a metal and is swapping places with the sodium to produce sodium chloride and water combined now with the the hydrogen combined with the OH, which makes water. So you got to be really careful. Neutralization is a type of double displacement.